Well, welcome back, folks. Today we are going to continue our work on stoichiometry by really focusing on gram to gram conversions. Now, this really is just an extension again of the first and second video. We did a gram to mole or a mole to gram conversion previously, and now we're just going to do some gram to gram conversions. So there really isn't a whole lot more to this other than just one added step. You'll see what I mean when we get to the practice problems. So our goals for today, what are our learning targets? Well, you should be able to successfully convert between grams of one substance and grams of another. So we're going to continue our work using mole ratios and molar masses. So instead of going mole to mole or mole to gram, we're going to start with grams of one substance, and I'm going to want to know what grams of another substance is in the problem. And again, no vocabulary terms. There's no emoticon here this time. Sorry to disappoint you. So the process is still the same. The only difference is that now we are starting with grams and we are ending with grams. So when we go through and do these problems, there's just going to be one added step. We start with grams. We're going to convert to moles. We're going to use the mole ratio to get to moles of what we're looking for at the end. And then we're going to use that information to convert back into the grams of the product that we're looking for. So let's dive into this practice problem. So tin reacts with hydrofluoric acid to produce tin 2-fluoride and hydrogen gas. How many grams of SnF2 is produced from a reaction of 25 grams of HF? How many grams of SnF2 would be produced with 50 grams of SN? Well, let's take a look here and see what we need to do. So we're given a chemical reaction here. So we're going to have to build that into a reaction. I also take a look, I've given two questions here. The question is giving us 25 grams of HF, and it wants to know how many grams of SnF2 are produced. And same thing down here at the bottom, except we're starting with 50 grams. So the first thing we need to do is write a balanced chemical equation. So I'm going to start with that up at the top. So we've got tin, which is Sn, reacts with hydrofluoric acid, HF, to produce tin 2-fluoride. So I know tin and F is fluorine, so tin is a +2. Again, that's based off of the Roman numeral. F is a -1, so SnF2. And then we're going to add to that H for hydrogen, but remember hydrogen is a diatom. It's part of Brinkelhoff, so that is H2. So now that we've written everything correctly, we need to balance our equation, and to do that we're just going to put a 2 in front of HF. Alright, so the question asks us how many grams of SnF2 are produced from a reaction with 25 grams of HF. So that's what we're going to start with. So we are going to start our stoichiometry with 25 grams of HF. Whatever units on top of the previous step must go on the bottom of the next. And the only thing we can knowingly convert grams into, again, is moles. And if you remember, we're trying to get it into a product. So we're starting with HF, and we want to go to SnF2. So we need to convert to moles in order to be able to change the chemical into a product. One always goes with moles here, and then you would go through and calculate the molar mass of HF, which is roughly 20.01. Go to the next step. Again, whatever units on top of the previous step goes in the bottom of the next. So you have moles of HF. And it's asking for SnF2, so we need to convert that to moles. We use the mole ratio from the balanced chemical equation, so there's a 2 in front of HF. There's a 1 in front of SnF2. And we need one more step here. And we're going to convert that to grams. Again, anytime we convert to grams, moles is always 1. And now we just need to figure out the molar mass of SnF2, and we find that information on our periodic table. The molar mass of this is 156.7. So now we just need to do our math. Now if we take a look here, remember, we have 4 significant figures in what we start with, so we need to have 4 significant figures where we end. So now we just plug this into our calculator and solve. And what we get is 97.89 grams of tin 2 fluoride. Okay, just like that. So again, it's all really just about plugging your numbers in, making sure you know where you're going. We start with grams. We have to convert to moles. We then use the mole ratio to get into moles of our product, and then we use the molar mass of our product to get it into grams of product. Pretty straightforward. But let's go ahead and do the second practice problem together. So in this instance, we're going to start with 50 grams of SN, and we're going to convert that to SNF2. So instead of using that as part of our mole ratio, we're going to start with 10. So let's start with that. So we have 50 grams of tin. Goes on the bottom. Grams goes on the bottom of the next step. We need to convert that to moles. We find the molar mass of tin on the periodic table. This is 118.7. Moles of tin to moles of tin 2 fluoride. Again, we use the coefficients here. There's nothing in front of SN, nothing in front of SNF2, so it is a 1-to-1 ratio. And lastly, again, we use 1 for moles when we convert to grams, and we just need to find out the molar mass of SNF2, which again, 156.7. We plug all our numbers into our calculator. Again, what we're looking for here, we need to have 3 significant figures in our answer. And we get amount of grams is 66.0 grams of SNF2. Right. Again, so you can pretty much see the process here. Start with grams, get it into moles. Use the mole ratio to get to moles of what you're looking for, and then use the molar mass to convert back to grams. Pretty straightforward. Let's move on. So, I mean, this video is kind of straightforward. You really should do gram to gram conversions. There's really not anything that's new or unique. We're just adding an extra step to it. So hopefully you have the idea of what we're looking for here. And as always, if you have any questions on converting grams to grams, feel free to let me know. Have a great day, guys. We will talk to you later. Bye-bye.